Well, hey there, kiddos. Here is your video on graphing strategies, but before we get to the graphing strategies, there are a couple of things I want to go back to talk about for the standard form. So I'm going to go to inequalities first, the notes that you actually had a full video on and were able to complete, because I noticed as I was looking at it that number 2 on those notes that I made a mistake, and so I want to correct that before we get too far. So number 1 I put up here just so that I could compare it to things and tell you a few things. We graphed this inequality on our notes. The x-intercept was 1.5 and the y-intercept was 3, and then we drew our line, and we knew it should be a dotted line, and so we drew our line, and then we looked at the symbol and we shaded, and that was all good for this problem because, oh, sorry, I don't like that pen. Grabbed the wrong pen. It's okay that we looked at it here and we just said that this was greater than and we shaded above. It worked out all right for number 1, but on number 2 it didn't, and I'm going to tell you why. On number 2, when we did this, we got that the x-intercept was 2.5 because it ended up being, my bad, it was 5. 10 divided by 2, it ended up being 5. And then the y-intercept ended up being negative 2.5, and so it was down here. And that's great. And we do still have a solid line, and so I'm still going to go ahead and draw in my line that needs to go through those 2 points in order to make my graph. Let me make that line and really go through my 2 points. The problem is that I messed up on the shading because this inequality right here, the number in front of the y has a minus sign with it. And so if I were to take this and solve it for y, I would end up dividing by a negative at the end. So I would subtract 2x from both sides, and so I'd get negative 4y is less than or equal to negative 2x plus 10. And then I would have to divide by negative 4 to get the y by itself. And when I divide by that negative, this symbol actually flips around. It doesn't matter what the rest of this turns into. My problem is that I just looked at this at face value and I didn't bother to think about this negative. When I divided by that negative 4, this symbol flipped. It didn't matter on number 1 because the y was positive, and so when I divided it was okay. But on number 2, because the y, the coefficient in front of the y, had a minus sign, it flips that sign. And so when I shade, I actually have to do the opposite of what it says, and I have to shade up here. And I know that in the original video I told you that we shade below, and that's incorrect. So I just want you to be able to make a note of that and make a note of this right here, because if that coefficient in front of, if b is negative, if the coefficient b is negative in standard form, then your symbol will have to be the opposite when you go to shade for your graph. So that takes care of that. Now let's finish up with these standard form notes that I just cut off on the video the other day. And so we'll start right here with this number 2. The first thing it says is to write this function in standard form and then answer the question. So we need this to be so the x and y are on the one side and the constants on the other. So step 1, get rid of these parentheses. So I have 3x minus 5 plus y, and then I'll distribute here, so I get 2y minus 4, as I multiplied 2 by both pieces. Now I need all my 2y to end up over here so that my x and y are on the same side, so I'll have 3x minus 5, and when I subtract 2y from both sides, y minus 2y makes negative 1y, and that equals negative 4. And so now I need to move this 5 to the other side, so I'm going to add 5, so I have 3x minus y is equal to 1, because when I add 5 to negative 4, I get 1. So now this is in standard form because I have all integers as coefficients for my a, b, and c, and then the a value is not negative. So I'll write down what I know. A is 3, b is negative 1, even though you don't see the 1, it's there, and then c is 1. So my slope is the opposite of a over b, and so the opposite of a is negative 3. B is negative 1, and when I simplify negative 3 over negative 1, I get positive 3. To find the y-intercept, I'm going to do c divided by b. And so when I take c, that's positive 1, divided by b, negative 1, I get negative 1 for my answer, so my y-intercept is at 0, negative 1. My x-intercept, the shortcut for that is to do c divided by a. And so then I have 1, which is my my c value. A is my a 3. And so I get that my x-intercept is at 1/3, and so my x-intercept is actually at this point 1/3, comma 0. So number 3, again, we've got to get this in standard form first. So the first thing that has to happen is I've got to get rid of this fraction, because we don't have fractions in standard form. They have to be integers. So I'm going to have to end up multiplying everything by 3 so I can cancel out this denominator, this fraction. So that leaves me with negative 2y. And then on this side, I have to multiply both of these things by 3. So I get negative 3x plus 6. So now I need this x to be over here with the y. So I'm going to have to add 3x to both sides, which makes it positive. So I end up with 3x minus 2y equals 6. And so I have all integers. My a value is positive, so we're in standard form. So I have a is 3, b is negative 2, and c is 6. And so my slope is the opposite of a over b. So the opposite of a is 3. B is negative 2. Sorry, that's a 2. The negatives cancel, and so I end up with 3 over 2 as my slope. Then my y-intercept is c over b. So I have 6 divided by negative 2. Well, 6 divided by negative 2 is negative 3. So my y-intercept is at 0, negative 3. And then my x-intercept, I'll do c divided by a, and 6 divided by 3 is 2. So my x-intercept is at 2, comma 0. So now let's look at a couple we have to graph. So this is the last part of those notes that got left off. Let me look at... We're just going to graph this first one right here, because then you should be able to make the jump to the last one. So number 4, we're going to graph it. We're going to find a, b, and c. We're going to find the slope and the y-intercept and all of that. But the easiest way to graph this is to just find the intercepts. And so you can use the shortcut, or you can do it the long way. Or it's not really the long way. You can do it the other way. So I'll show you both ways. So if I want to find the x-intercept, I ignore the y value. So I have 3x is equal to 21. And I solve for x, so I get that x is equal to 7. That means my x-intercept is at 7, 0. And then my y-intercept, I do just the opposite. I will ignore the x, and I will have negative 7y is equal to 21. And then I'll divide both sides, and I'll get y is equal to negative 3. So my y-intercept will be at 0, negative 3. So that's one way to do your intercepts. And then once you have them, you can plot your two intercepts, 7, 0, and 0, negative 3, and you have 2 points. You can make your line so that you can have your graph. And so I have my line, I'm going to make my graph, and so there we go. And since it's just an equation and not an inequality, I don't have to worry about where do I shade, up, down, whatever. That's my line. Now, if I wanted to do it the other way, and I'm going to because I need to fill in this information down here, I know that according to my problem, A is 3, B is negative 7, and C is 21. And so my slope is the opposite of A, negative 3, over b, which is negative 7, and so the negatives cancel, so my slope is 3 over 7. And if you look, we'll count up 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7. That is a new point on the line, so the slope works. The y-intercept we already know, but we'll use the shortcut just to be safe. So the shortcut is C divided by b. So 21 divided by negative 7 is negative 3, which is the same y-intercept we found a minute ago, and it's the same math as well. We did 21 divided by negative 7. And then the x-intercept is C divided by A, which turns out to be 7, which is what we found up here, and it's the same math even. We ended up doing 21 divided by 3. I just took all the x's and y's out of it and just worried about the coefficients. So that's how we graph with standard form. If you can find the two intercepts, you just plot the two intercepts and go with it. So that's that. Now let's talk about some strategies for graphing. So these are the notes that you need for Friday's class. So given the following information, we want to graph each equation and then write the equation in slope-intercept form. And so they give me 2 points. So for number 1, I'm given 2 points. I'm just going to plot the 2 points and make a graph. So they make it real easy. So I have 1, negative 6, and then I have 5, positive 6, and I need to draw a line through those 2 points And so there's my line. That goes through those 2 points. And then, oops, it asks me to find the slope. And so I need to find the slope, and I have those 2 pretty points. So let's see if there are any other pretty points on here now that I've graphed it. Looks like there's a pretty point right here at the y-axis or the x-axis. So if I draw my right triangle, looks like I go up 1, 2, 3, 4, 5, 6, and over 1, 2. And so that means my slope is 6 over 2, or just 3. And so let's see if that works. If I go 1, 2, 3, and over 1, yes, that's a point on the line. So my slope is 3. My y-intercept is down here at -9. And if I count down 1, 2, 3, and over 1, that's still the same slope. And so I have my slope and my y-intercept. So in slope-intercept form, it's 3x minus 9. So number 2 gives you the slope and a point. Well, I have a slope and a point. I'm going to plot the point. So I'm going to do 2, -3. And then I'm going to use my slope, which is 3 or 3 over 1. So I'm going to count up 3, 1, 2, 3, and over 1. Up 1, 2, 3, and over 1. I can just make points all day long. 1, 2, 3. So I have points I can take, and I can now connect them and make a line to go through those points. So there is my line that passes through those points. And so now to put in slope-intercept form, well, I have the slope, so it's going to be 3x, and then it looks like my y-intercept, oh look, again, it's at -9. So it's exactly the same equation. I was just given different information. And so if you look over here, this graph does pass through 2, -3. It does pass through that same exact point, so they're the same line. I just was given different information. So now number 3 here, they give it to me in standard form. It says 3x minus y equals 9. Well, if I want to graph that, I need the x-intercept and the y-intercept. So to find the y-intercept, we'll start with it. To find the y-intercept, remember that's going to be c divided by b. So if I look at my problem, c is 9. B is -1, and when I do 9 divided by -1, I get -9. So my y-intercept is going to be at 0, -9. And then my x-intercept is c divided by a, and so I'll take that. C is 9, a is 3, and 9 divided by 3 is 3. So my x-intercept's at 3, 0. So again, I can draw a line through my 2 points. And hopefully you notice that again, we have drawn exactly the same line, because I still have that line, has a slope of 3, and we can double check that if you aren't sure. Remember, to find the slope, it's the opposite of a, which is -3, divided by b, which is -1, and 3 divided by -1 is 3. So it is a slope of 3 and a y-intercept of -9, so it's still 3x minus 9. Well, I've been given 3 different pieces of information, and I've made the same graph every single time. So guess what's going to happen with number 4? Well, let's see. The y-intercept's -9. Yep. The slope is 3. Up 3 over 1. Up 3 over 1. Up 3 over 1. It looks like I have again drawn the same line. The point is that no matter what information you are given, you can always plot it and graph it, and you can end up with the same equation even if you're being given different information. And so I have been given different pieces of information. I was given 2 different points, then I was given a point and the slope, and then I was given a slope and the y-intercept, but every single time my equation was still 3x minus 9. So if you were given, it depends on what you're given, how you're going to deal with the problem. So let's talk about some strategies here. So things that you need to think about, okay? If you were given 2 points and you're asked to graph it, plot the 2 points and then draw your line, and then to find the slope, find a pretty point, do your rise over your run. That's an excellent strategy. That's a really good way to do that. For number 2, I had the slope and a point, so I plotted my point and then used the slope to make a new point, which is just exactly what we did when we did point-slope inequalities. We took our point, used our slope, made our line. Once you know that, then you can find your y-intercept so that you can write your equation in slope-intercept form. Now, number 3 gave me standard form. The easiest way to graph given standard form is to find the x-intercept and the y-intercept. Use the shortcuts so that you can quickly find what the x and the y-intercept are. I plotted those two, and then I just did rise over run so that I could find out what the slope of that was. I can also, because I have standard form, and I know my shortcut for slope is negative a over b, I can use that shortcut as well to find my slope. And then for number 4, well, they just flat out gave me slope and y-intercept. Begin with the y-intercept. We always begin with b, and then we use the slope to move and make a new point. So we went up 3 and over 1. We just used our information. So it just depends on what you're given, the strategy, what you're going to do. But if you have enough information, if you've got a point and then some way to make a new point, like the slope, or a way to find an intercept, do that, plot your 2 points, and then you can find your slope really, really easily. So that is strategies for graphing. And I've caught you up now, hopefully, on inequalities and fixed some problems with, I take that back. I fixed some problems with inequalities and then caught you up on standard form. We will get this all wrapped up and back together when I see you guys tomorrow. Have a good rest of your day, and I'll see you Friday.